reversing? 394. 394.
Okay, I'll start. From start. Okay, so I was telling somebody the difficulty of, first of all, this program is made, I don't know by who exactly, but Mendy Darren, it was made for him. He had arranged to have this program made. Someone that's very into Kiddush Hachodesh. He has videos on Chabad.org. I was just starting to mention that one of the difficulties in teaching these halachas is that on one hand, every detail is affected by all the other details, but on the other hand, you can't say everything at once. You have to say one at a time. You know, Rashi, if he has two Perushim, he says the better one first, and the one that's not as good second. What if they're both equally good? Can't write them both at the same time. So he'll say something, for example, there's two Perushim in this. So he's telling you there's two, and they're both equal. Sometimes he'll even emphasize it by saying, ha'echad va'echad, not ha'echad va'asheni. So when it comes over here, one of the difficulties is what you say about the sun is not really true, because once you get the second piece of information, it changes what you said beforehand. So it's one of the difficulties in doing it. It's almost like you want, eating each ingredient of a cake separately. It doesn't work. Also, although it doesn't taste good. It's to this, to that. When you have it all together, then it tastes good. When it comes to this, you're doing it one at a time, and you're sort of lost and feeling your way through it. And then at the end, each thing is affected by the other thing. So it's just good to keep that in mind. That it's there's a difficulty in teaching, and that's part of the reason. Very often you'll go to classes and have a difficult time with it. That being said, so it's mentioned, I think, on the flyer about 3 cycles of the sun and 2 cycles of the moon. Even the word cycle, for example, when you hear cycle of the sun, and you hear what the cycle of the sun is, you ready to imagine that's what the cycle of the moon is. But it's the same word as being used, but they mean different things. So for example, when you say a cycle of the sun, it means still it comes back to its original place in the sky. When you say cycle of the moon, it's not when it comes back to its original place in the sky. It's when it comes back to its original place relative to the sun. So it comes back to its original place actually every 27 days. But in the meantime, the sun moved 27 degrees. We'll get to that in a moment, so the moon has to catch up. So it takes it another 2 days. So when it comes to the sun, there's generally, we say 3 cycles. So the simplest cycle is, let's say over here, let's look at this image over here. The sun goes around the earth every day, right? We see the sun every day. It goes all the way around every single day. So let's just imagine the sun is now right above us. A day later, it goes all the way around, and it's in the same exact place. But the truth is, what happens with the sun, it doesn't move every day a full circle of 360 degrees. It moves 360 around, everything's around, +1. But it ends up right on top of you. And the reason is because it's also moving in its own track 1 degree back. So it's almost like it moves 361 and back 1. So an example would be, let's say you're on a train that's 10 miles long. It's moving 80 miles an hour, and you're in first class, and then they tell you, the other side of the train could also be used as first class. It's also the front. But we had some technical difficulties. We had to switch it around, and this is first class, but your luggage is all the way there. It's 10 miles in the other direction. We don't have anybody to bring. You're going to have to go get it. So you start walking 3 miles an hour towards the back of the train. It's going to take you 3 hours and 20 minutes to get there. During those 3 hours, you're walking straight 3 hours and 20 minutes. While you're walking in that direction, so you're moving, bottom line, you end up moving 77 miles an hour because the train's moving you 80 miles an hour. You're moving 3 miles an hour. So the sun and the moon, we'll see, I think actually has 4 tracks. The sun is moving along what you would say is the equator, even though there's really no equator. I don't have a ball here, but an equator basically is a term, I'm saying in language, for something which is turning. And the axis is the part that it's turning on. The axis is not really moving at all. It's moving everything else. And the equator is the part that's moving the most. So this part of the ball, some areas of here are equal. But if it was coming out over here, this part's moving the most. The part over here is not moving as far. Exactly, the biggest rotation is the equator. But the earth is not moving around anything, and it's not spinning on its axis. That's what the Torah tells us. It's not moving at all. So there's no real equator. But you could use the term equator because there are things moving around the earth as if, that being the center of it, going around it. So the sun moves every day 300. Let me see if we can do that movement again. I'll do it this way, right? 1 second. I want to see what it looks like up here. So the sun's moving every day 360 degrees +1 this way. But then it's moving on its track, that's like this, 1 degree back. So it ends up in terms of what you call the longitude in the same exact place. Because it went 361, but back 1, it's in the same exact place, but just up a degree towards, if it's at the beginning of the summer, towards the north, making it summer by us. and at some point it'll end up going down towards the south on this side. And so it'll be going down to the south, and then we'll have winter and they'll have summer. So the sun has those two movements, the 361, and then on its own track it goes back 1 degree. And then the moon, which affects, so what does that affect? That affects that there's 2 cycles. One cycle is a daily cycle, that it revolves around the earth entirely, all the way around. And then another one is for it to come back to the same place it is in its track. Because right now, let's say it's right in the center over here, heading towards the north, and then it's going to go towards the south, all the way down to the south, and then come back again. For it to make that full cycle, we'll take it, that's basically a year. 300, there's different opinions, 365 and a quarter days.
So it's trying to do what's taking it up in season.
Exactly. It takes it 23 degrees, 23 and a half degrees. That's the tilt is.
It's a trip. Could up to 20.
Up to 23 and a half.
So
Exactly.
that's going up to 23.
And then it comes back down
That's
again.
the season.
Exactly.
And the day is, it's just going, it's going one more. So that's why it's like back to 360, but it's off.
Again?
It moved in the direction of the day together.
Meaning around, so to speak, the equator, 361.
Yeah, but it moved a little bit. It moved a degree.
In its own track.
Off the equator.
Off the equator, exactly.
Or
Either
off
to
or
the,
closer, whatever.
yeah.
Depending on the summer or winter.
Exactly. And so that affects basically what you said, the season. So if somebody tells you it's Tammuz or Lahavdil June, then you know where the sun is. It's up north. You know something about the world. It's going to be warm in the north and cold in the south. Somebody tells you it's Tevis or let's say January. So you know the sun is down south. That means it's going to be winter up north and summer down south.
Right.
When it comes to the moon cycle by the Goyim is a completely arbitrary thing. It's like, you say Tillim and Shams Avarchim, people get the Kapitel Kuf Yates, what do? Oy, today you can't do it anymore, you say Kapitel Kuf Yates every day. But what's Oy? You're saying Tillim for an hour and a half, 2 hours. What's Kuf Yates? That's what matters, 5 pages? The reason is because it's just long. There's no beginning, middle, end. You don't feel like you're getting anywhere. So it used to be 10 months. Then came a guy, Julius Caesar. He wanted a month in his name, so they made July. Then came another guy, Augustus. He wanted a month in his name. They made August. And both of them maybe had big egos. They each wanted a month of 31 days. So we have 2 months of 31 days arbitrarily. And meanwhile, February has 28. If you'd really divide it properly, logically, you have 365 days. You'd say, okay, every month has 30 days. There's an extra 5 days. So 5 months will be 31, and 7 months would be 30. But if I tell you it's the 5th, if I tell you it's January in the Geisha calendar, or June, you know something about the location of the sun. If I tell you it's the 15th of the month, you don't know anything about anything. All you know is that they made this division of months so that it can be broken down. Same thing with the week. If I tell you it's Tuesday, you don't know anything about it. They could have made the week 5 days or 10 days. They figured 5 days is not a long enough week. They actually used to be different weeks historically. And then 10 days is too long. So they picked 7 days. But there's nothing inherent to it. Theoretically, it could have been 6 or 8 or any other number. Same thing with the months. They could have made, instead of 12 months of 30, 31 days, they could have made 10 months of 36 days. When it comes to Torah,
the only thing is that the only thing that you do have is season.
Season is that's the sun. That's related to the sun. No, but if you would have had 10 months, but if you would have 10 months, then you would have make the different associations of whatever the names of them would be. You'd know that this month is when where the sun is here is summer, and that would be winter. Right. But that's the month is the section of the year, but I'm talking about the days that are the section of the month. That would mean nothing. Even though month, by the way, is connected to moon. That's where the word comes from. But in Torah, the month basically is, this is like the basics of Hilchos Kiddush Hachodesh, is the movement of the moon. Now the moon, you'd imagine, for example, those moving floors in the airport. So imagine you have a floor as wide as this room over here, moving 10 miles in one direction. There's a smaller one within it that's moving with it, but that's also moving in its own track 5 miles, and a smaller one in that moving another 2 miles. And then, like in the kids, they go on the amusement park rides. They're one of those things that also moves in circles. That's what the moon is doing. The moon is moving first with the Galgal Ayemi 361. Everything's moving 361 with the Galgal Yashi. Then it's moving in the other direction, like the sun is, along the same exact track, but we'll see a little off. 24 degrees, and then there's another movement in that track, 11 degrees. So that's why you just say 13 degrees. It's moving 13 degrees because there's 24 and 11. It's 13. And then it's also moving in a round thing like this.
Why is it 24 and 11?
Because it's moving this way, 360. It's moving along, the equator, let's say, 361, right? Yeah, in addition, it's moving in its own track, this one, 24 degrees. But within the same track, it's also moving. It's a different force that's pulling it 11 degrees.
Which is the force 11 degrees.
Also on the same track. So that's why they just say 13 degrees, because if you're moving 24.
1 second, what's moving backwards on the...
Just like the sun was moving back 1 degree every day along this thing, the moon is moving on it 24 degrees.
And its own goggle is moving?
No. In this track, the same track, it's the goggle of the what's it called, of the mazalis.
Right.
The bottom line is it's moving 13 degrees. The sun is moving back 1 degree, right? It readjusts to go 361 and then goes back 1 to stay in the center. The moon's moving 12 degrees. That's why if somebody says, like what we saw in Rambam today, they're going to ask the person which direction were the karnayim. If somebody tell you, I saw the moon tonight, you'd be able to tell him where he saw it, the time of the day he saw it, if it's the beginning of the month, and if it was like it was the shape of like of a banana, which side he saw. Because what happens is the sun rises right in the east over there, and what's happening is the moon is moving to the west, right? Everything's going around 361 degrees, 361. The sun went back 1 degree, the moon went back 13 degrees, so it's 12 degrees this way. That means the first opportunity to see the moon in the new month, it's going to be to the east of the sun. And you can't see it in the middle of the day. It's like you can't even look at the sun. Let's say there's somebody put up a candle right in front of you. Here's the sun, and they put a candle. Look at the candle. You can't look. It'll hurt your eyes. When would you see the moon? You'd see the moon after, right? So let's say what happened. This is day 1. They were together. It was a new moon. It goes around. The sun went all the way around, plus then it went back 1, so it's in center. The moon, meanwhile, went back 12. You can't look at this point. You wait till the sun goes over the horizon. It's not so strong and bright anymore. It's already not seen. And then you can see the moon. And what part of the moon you're going to see? You're going to see it like this. Because this part of the moon has the sun shining in it. If the person said they saw the moon like this, you know that it's either he made a mistake, niskasher of him, or he's saying a sheker, or he's lying. It's not possible that he saw the moon this way. And he couldn't have seen it in the middle of the day. He had to see it after the sun already set, so that it's possible to see it. I'm trying to remember the different points that they put on the flyer. So there's the daily movement of the sun. That's really connected to the Galgalachi. There's the yearly movement, which is connected to its own movement on its track, which takes 365 and a quarter days. Then there's another movement that everybody talks.
And the monthly movement.
Okay, then there's the moon. The moon has its daily movement every day. It goes around, just like the sun does with everything else, but it's moving away 12 degrees. One of the things that's interesting about the moon is that it's equally out in the daytime as it is in the nighttime, the same amount. It's in the sky the same amount, because it started over here, and then it went, I'm going to see if I have the presentation up here. The difficulty of doing this is you can't do it in 2D, because, I'll show you the different presentations I made. The reason I didn't pursue it fully is because you can't do it in 2D because it's inherently a 3D thing. But let me just pull up the Kiddush Hachodesh. Here's Kiddush Hachodesh. I think it's the third one or the fourth one. No, the third one is the most basic part of what you could see here. It's not, is it? No.
Yeah.
The third one shows the most basic part of Kiddush of the moon and seeing the moon and the sun. So when it's like this side of the moon, where is this thing here? This side of the moon is dark because the sun's not shining in it. The moon is like, maybe it's somewhere reflective, but it's almost like you came into this room, it's completely dark. You can't see anything. If I took a very strong flashlight that was a very focused light, and I've shown it here, it'll be light, even though this thing's not light, just because there's light on it. So when the sun is shining, this side of the moon is dark because there's nothing shining on it. This side of the earth is dark because there's nothing shining on it. Theoretically, the person's standing up here in the daytime. Now this part of the moon is gray. Gray represents that it's light, but you can't see it. It's a helfternish. It's like somebody's going to put a light downstairs. It doesn't help you because you're upstairs.
Right.
So even though this is being lit up by the sun, in terms of the person seeing it, it's irrelevant. It's non-existent because you're not in that direction to look upwards. This is the middle of the day. This is like by the Moiled, right? Now, this is not showing the whole story. The whole story is that it has to go around. Everything's going around. Here it's more trying to show how much of the moon you would see. So one of the problems, for example, of doing 2D is this part is being lit up. But when something is 3D, it's not a pie. Imagine you had a ball, a whole ball, and this part is, and something's over here lighting it up, you're going to see a full sliver. You're not going to see just a pie, even though this is an exact thing for a 2D. And then as you're going through it, so that's why I showed it, you would see is up there.
Yeah, that's very good.
And then as you go through it, you see more of the sun, more and more of the moon appears. And you could tell when it would be during the day. At this point, it's towards, when you're seeing this much of the moon, which is more than this, right? It means that it's already towards, even, it would be closer to the nighttime.
It's not
Now, when a
direct.
quarter
It's
of,
not direct.
when a quarter is lit up, now a quarter is not lit up, it's always half, but this part doesn't help you because it's out of your line of vision. When this is lit up, you see a half a moon. You don't see a quarter of a moon. Also, when the whole thing is lit up, it's really just this half, but you're seeing it as a ball. When this side of the ball is lit up, you see a full, you're seeing a full circle. You're seeing a full circle, even though it's only look like half. So also over here, what you're seeing is like a whole half of a moon. So this would basically reflect, and then you can also see what side of the corners you would see. The person saw. At this point, you can't see the moon in this direction. You'd be seeing it in this direction. And then over here, you'd be seeing a full moon. That would be like just indicated there.
And the reason why you're seeing a full moon there is because it's not blocking because that would be my eclipse. It was right below it.
Well, the eclipse would be...
If it was right below it, but the way this picture is...
Right, the other eclipse would be at the beginning of the month, really. When the sun is above the moon,
right.
That in theory would create an eclipse. But we said that the moon...
I know, but still, why are you seeing the light?
You're saying even over here. Because it's
off.
Right, it's off. I actually didn't mention that, about the degrees that it goes off. The Rambam writes today when it could be, right? He says it's going to be like, it takes about 2 days where you can't see it. It's like between a day and 2 days. It don't have to be at the end of the day. He talks about today, what if they saw the moon, right? What if they saw the moon? The Bezdin themselves saw the moon, because people wouldn't be able to come to them. They saw the moon right before the sun set. So if there's enough time to say Mekudesh, they may say Mekudesh right then. Otherwise, they have to wait till the next morning. 2 of them testify to the other one, and then together as a Bezdin, that was in today's Rambam, they declare the new month. Let me show you this and this thing again, sort of what you were saying about the thing. So the moon, so that was the other thing with the moon. The moon goes along this track 13 degrees back, which really means 12 degrees off, because it went 361. 1 is to make it up, and then 12. But besides that, the moon also goes off of this thing, which goes 23.5 degrees off the equator. The moon goes around this, 5 degrees above or 5 degrees below, which basically affects that there shouldn't always be an eclipse every month. Otherwise, every month would be an eclipse. And like he said over here in the Shir, the moon takes up about a half a degree. It's about a half a degree in the vision. So if it moves 10 degrees, so there's about 20 spaces. 20 moons could fit in the area that it moves between.
What's the
between here and here?
What's the pattern of going off? Like the sun, we know it's based on the season. Say, right?
It goes along the same thing. The sun, it affects the season. That's what the sun affects. It's not based on the season.
I know, but I'm saying, but it's a pattern that goes off the equator and goes more to 23.
23 and a half. Right.
23 and a half, and then it comes back slowly.
And then it goes. Right. Right.
So the moon, what's the pattern?
Does the same exact thing, except that it also moves. So that's the example I was giving, like you go on a ride that also goes in a circle. The moon is also moving like in a circular thing along this thing, so it could be off or on of this thing, but it's based on it. In other words, it's moving. It's moving on the track.
The pattern is the exact same pattern, the same up to a certain amount of degrees during the month. When does it go off the pattern? I'm not sure.
You're saying what exactly is that movement? I'm not sure exactly how it works, but it's all based on this track, and it just has an additional movement that moves it off of it.
Deviates off the track.
Exactly, it deviates, so it go up to 28 and a half, and it could go down as low as 18 and a half, because this is 23 and a half, and it could go 5 degrees above it or 5 degrees beneath it.
Oh, it's not within the 5 degree. It has to be outside of it.
It's basically, it has 5 degrees above it and 5 degrees
so it does
beneath
more.
it.
It exaggerates it more. If the sun goes up to 23.
23 and a half, and it goes up to 28 and a half, or potentially it would be at 18 and a half.
18 and a half.
It's almost like, imagine you have this thing going along a track, and it has a 5 degree string, and it's swinging in circles. So it's going along that track, but it's swinging. So it could be up 5 and because it's a 5 degree string. So it could go up as high as 5 or low as 5. So it'll deviate, and sometimes it'll be exactly, and then you'll have an eclipse.
And it could also be, it could be, okay, so it could be, but it could also be at 18 also, it could be at 17, 16.
No, only up to 18 and a half.
No, I'm saying 18 and a half the most, but I'm saying it could be.
Yeah, because as I'm saying, when it's at the highest, when the sun's at the highest point, at 23 and a half, then the moon would be anywhere between 28 and a half and 18 and a half. But as the sun goes down, the sun's going up to 23 and a half. It also goes from 0 to 23. Anywhere in between that, wherever it is, the moon will be within 5 degrees above or below it, but not more. There was another point that was mentioned, was a 28-year thing. The 28-year thing, Ba'atzim, is really, I was going to create a presentation that the 28-year cycle is really a purely mathematical thing. It almost has nothing to do with astronomy. 28-year cycle is simply, when will you have the moiled, when will you have the sun at the same place, and it should be the same day of the week. Meaning, it's going to be 20, it basically goes at, I'm trying to remember the cheshbon again. So you have a year, it's 365 and a quarter days, right? So that means the sun, if you take, I'm trying to remember what the cheshbon is. It has to be full weeks because they're trying to get it on the same day of the week. Let me pull up a calculator and show you how it would work. But I'm missing one detail of it. Here, so basically you have 365 days in a year. 350 divides perfectly into weeks, right? Because 7. 364 also. So what's left? A day and a quarter. A day and a quarter is left. So let's say you do 364 divided by 7. It divides perfectly. It means you'll come, it's 52. It's a perfect number. You'd come back to the same day of the week. But the year is another day and a quarter. So how many times will you do a day and a quarter to come back to a full week? It's basically going to be, you're going to need 28 years. 28 times 1 1/4 equals 35, which is exactly divisible by 7. You need a number that's divisible by 7, so it's the same day of the week. So it's really a purely mathematical thing. You're trying to get the same day of the week to line up at the end of a year. So at the end of the first year, you come a year later, and you start off, let's say, Monday, 6 o'clock. What's a year later? A year later is 365 days and a quarter. So 365 days is going to be not Monday, but Tuesday, and not 6 o'clock, or let's say right when the sun's in the middle of the sky, it's going to be a quarter of a day later. You're trying to get back to Monday. I want the sun to be Monday right here, not Tuesday over here. It has to be specifically Monday and here. It's going to take you 28 years for that to happen. The next year is going to be a day and a quarter later. What's that going to be? It's going to be Wednesday or whatever, Thursday with the sun down here. In order to get there, you have to have a number that fits exactly into 7 and perfectly. And what that's going to be, you could do the math. Do 35 divided by 1.25. Oh, yes, I'll do it. 35 divided by 1.25. Oops. 35 divided by 1.25 equals 28. So basically, 28 years. Exactly. That's really all it is. It's a purely, I was going to do a thing that you could see it more visually. It would get you back to exactly that point. I think there's one last presentation here that would, oh, this is not it. Let's see. Okay, this is basically showing, if you look at the moon, if the moon was moving on its track 13 degrees and the sun is moving on its track 1 degree. So the problem over here is that it's making the move east and west. Really, it's on their track. East and west stays in the same point. So if they're moving, if you'll actually count, we started right in the middle. 1 day, 2 days, 3 days. This is all exactly, by the way. It's 1 degree and this is going 13 degrees. 4 days, 5 days, you'll count. It's going to be exactly a month. 6 days, 7 days, 8 days, 9 days, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, around 27 days, it comes back to its original place, between 27 and 28. 28 and 29, it's around 30, is in order to match up with the sun. The problem with this is that it's 2D, and this is not accurate, because the sun didn't move to the right. The sun's still in the middle. You'd have to see it on the it's more the point is like the sun went all the way around, right? 360 degrees, 361 degrees, and then went one up in its thing. Went one up. The moon went 12 more. And then the next day they went all the way around and the sun went one, but then it went up again. It's basically going to take it, the sun will stay in the center, in the middle, and it's going to take it's in the middle of the sky, right? But on its track, it moved, meanwhile, 27 degrees. 27 out of 360. It went up 20. It's not 27 high, 27 along that thing. Moved 27 degrees. So it's over here, but 27 degrees off. The moon has to catch up those extra degrees, which takes about 2 days because it's 13 degrees every day. 13 times 2 is 26. It's right by 27. That's why it takes that extra amount. Okay, we'll end with that.
Yeah, very good. Helped a lot, by the way.
Okay, I'm glad. I was telling when I gave a class on Sunday about it, I was telling people like that. By the way, that model is a very good model. When I saw that model originally, I was like, oh, you have to make something nicer. But when you start learning the material, you start realizing how good of a model it is. It's very hard to make a proper model because